Okay, so I'm going to take a look at one more, just so that you can kind of see how this plays out. So one more. I want to integrate 2x cubed plus 11x squared plus 28x plus 33 over x squared minus x minus 6. Tell me things that you see. The numerator is greater than the denominator. You can factor the denominator. Good. Lots of things that you're seeing. Good. However, this trumps. I know. See, that's why I want to do this one. Because you get in that mode all the time of just, oh, partial fractions, partial fractions, partial fractions. Well, I didn't know it's partial fractions, right? If we're looking at this, always look at that first. Is the numerator degree greater? Well, do your little division. Let's do some division. You have to do long division when you have these kinds of exponents. So 2x cubed plus 11x squared plus 28x plus 33. But you do it the exact same way. You look at these first two terms. And you say 2x cubed divided by x squared is how much? Is an x. Good, right? 2x cubed divided by x squared is just going to be 2x. Ooh, I almost forgot my 2. How about that? And then again, 98% of success in mathematics is organization. Line up those variables. Now distribute that. And I've got 2x cubed minus a 2x squared minus a 12x. Change those signs. So now I end up with 13x squared plus, what's that, 40? Plus 33, because you drop down that next one. Then you go back at it again. 13x squared and that x squared, divide that out. 13x squared divided by x squared is just a 13. So when I add 13, then distribute. So 13x squared minus a 13x. What's 13 times 6? 78? Did you guys get the same thing? I think so, 78. Change your signs. Now 40 plus 13 would be a 53x. And 33 plus 78, 8, 9, 10, 11, carry that 1, is 111. Okay, that's my remainder. So this is plus 53x and 111 over x squared minus x minus 6. So what I'm actually integrating here is 2x plus 13 plus a 53x plus 111 over x squared minus x minus 6. This, easy integration. This, partial fractions. So not only did we get to do the division, which is awesome, now we get to do a little bit of partial fractions. So I'm going to pull this one out and just break this down in partial fractions, then we'll integrate it all together. So 53x plus 111 over, oh, we didn't factor that, but this is x minus 3x plus 2, right? You know that one. So a over x minus 3, b over x plus 2, getting that common. So I've got 53x plus 111 is equal to, I'm going to write this up here. I know this x minus 3 goes, and this is x plus 2, and this one's x minus 3. ax plus 2a, bx minus 3b. So now I have a plus b is the coefficient of x. Negative 2a minus 3b is my constant. So I have a plus b is equal to 53. Negative 2a minus 3b is equal to 111. All right, well, that's a nice, easy system of equation, right? I'm going to multiply this top by a 2 to eliminate those a's. So I've got 2a plus 2b is equal to 106, I do believe. Nope. So now I end up with negative b is equal to 217. So b is 217. Did I do that right? Oh, I hope you guys were yelling at me. Oh, I'm so proud of you. Look at me. 2a, negative 2a. See what I'm talking about? I'm so glad that I did this. Well, I'm not, but I kind of am, because look at what's happening there. When you have this problem, I'm going to erase this part of it because I'm looking at that number going, dang, that's big, right? So when you have these, look how important that negative sign was. Totally threw it off. So then what did I do? I go back and look, man, did I write all that down correctly? These are problem solving skills that are super good to do. Now, I'm not going to be getting rid of that A, I'm going to get rid of that B, because one's positive and one's negative. So now I have 3A plus 3B. Now what's that, 159? So I've got 5A is now equal to 270? Holy cow. Divide by 5. 5 goes into 27 5 times. Carry the 2. And that's 4. So 54. Okay. Oh, yeah, that's not too bad, because then look at B. I've got 54 plus B is equal to 53 when you plug this back in, right? Minus 54, so B is a negative 1, so that's not as bad. Okay. Now, we integrate. Go back to black. I'm going to integrate 2x plus 13, and then my partial fractions. So plus 54 over x minus 3 minus 1 over x plus 2. And that's easy integration. So this would be x squared divided by 2 is just x squared, plus a 13x plus 54 natural logs here of x minus 3. I'm going to scoot this over. Beauty of technology, right? Run out of room, just scoot it over. Minus the natural log here of x plus 2. And then plus your c, of course. Nice. If you want to put those two together for the natural log, you can. But remember, I always say you don't have to. You can leave that right there. Nice, right? Okay. Always look. Is the degree in the numerator greater? If so, do your division first, or the same, right? Greater or the same. Do your division first, then get into your partial fractions. If not, look at factoring that denominator, get into your partial fractions that way. All right? Okay, you guys have got this. Go rock the socks off of some